Hello, welcome once again to my YouTube channel for the continuation of continuous random variable. Now I am going to basically handle problems that involve sketching a function and using that sketch to find the value of any given constant. Now we have a very simple sample question here that is given as f of x as kx for the range 0 less or equal to x less or equal to 2, then k into 4 minus x for the range 2 less or equal to x less or equal to 4. They want us to sketch the function and then use it to find our value of the constant. Now, what we do, I am going to begin with the first range, 0 less or equal to x less or equal to 2. We can easily see that our function f of x is already given as kx. So if we have the function kx, I can even summarize this with a simple table. I will summarize it with a simple table where I have the values of x, then I have the values of f of x. Now, when we get back here, the values of x we're going to consider are going to be 0 and 2. So I will have 0 and 2. Then I look for the values of f of x. How do I do that? By simply substituting for 0 here. Automatically that comes to 0. When I substitute for 2 here, where there is x, I will have 2k. So it means the coordinate here are going to be 0, 0, comma, 2, 2k. Then I also do the same for this other range. So I will say for 2 less or equal to x less or equal to 4. I already know my function f of x given as k into 4 minus x. Then I will also draw a simple table here. I'll draw a simple table here that will help me to get the coordinates. I'll draw a simple table here. So I have x again and f of x. The values of x this time around are going to be 2 and 4. So what I do is, when I substitute for 2 here, automatically I'm going to get 2k. When I substitute for 4, I will get 0. So it means the coordinates are going to be 2, 2k, and 4, 0. 2, 2k, and 4, 0. So those are going to be our coordinates that we're now going to go to a graph and plot. But we need to know the nature of our functions. For example, as you look at this, the highest power of x is 1, so it qualifies to be a straight line. When you also look at this, the highest power of x is 1, so it is also a straight line. So we can now go on and do the sketch. Okay, so we now have our axis already labeled. So we are labeling the horizontal axis as x and the vertical axis as f of x. But remember, it is small f of x. Then from here, we're going to do the plotting. Because we're going to do approximations, basically because I don't have a graph paper here. So I will have 0, 0. 0, 0 will be some point here. Then I have 2, 2k. 2 is here and 2k is somewhere up here. So I can plot a point there. I know that this point corresponds to 2. This corresponds to 2. And then what I do, because they said it is basically from 0 to 2. The range was given as 0 to 2. So I first join this with a straight line. I first join that with a straight line. And I continue to the next. I have 2, 2k. So they are sharing the same coordinate here. Then 4, 0. 4, 0 will automatically be somewhere here. Then I can join this also because it is also a straight line. Now, something you're not supposed to forget is labeling or naming each of the parts of your graph. We know this part as f of x is equals to k into 4 minus x. We also know this part as f of x is equals to kx. Good. Now this is already our sketch that was required. Now we want to use this sketch to find the value of the given constant. In this case, our constant is k, without going through the process of integration. Now, number one, you realize the figure we have come up with is a triangle. And we know the formula for getting the area of a triangle. So what we do, we get area under this graph and we equate it to 1. So it means I will get the area of this. which is going to be using the formula a half base times height. So I will say when I get a half times the base is going to be this distance here, which is 4 units, times the height, which is 2k units. All this should be equated to 1. It is a must, you have to equate it to 1, basically because the total probability or the area under this curve is 1. Then from there we can easily see that the 2 and the 4 can reduce to 2, so it means we shall have 4k, because we have a 2 here. After reducing 2 by 2k, you get 4k is equals to 1. And therefore, your k comes to 1 out of 4. Your k comes to 1 out of 4. Now, after writing the value of k, it is smarter enough to redefine the function by substituting back the value of k. So we shall now say, therefore, f of x is now going to be a quarter x for that given range, then a quarter into 4 minus x for that given range. Then don't forget the 0 otherwise, because this basically tells you that for any other values of x which are not these values captured in these ranges, the probability is 0. So that is what happens. I'm also going to now add you one more example for such an example. I mean for such a question that will help us get the value of a constant from our graph after sketching it. Okay, so we are given another question here. Written a continuous random variable. In short, x has a PDF. PDF means probability density function. F of x, where f of x is given as this, as sketch y equals to f of x, hence find the value of k. Good. Now we are going to still follow the same procedures like we did in the previous question. And what are we going to do? We are going to begin with the very first range. I'll say for the range 0 less or equal to x less or equal to 2, we can see that our f of x is already k. F of x is already k. So if you want to have the coordinates, shall draw a simple table again, just to save time, or someone can do without a table. Then we shall have x, f of x. So the values of x we're going to be considering as 0 and 2. Now, when you of course look at this function here, it is simply a constant. It does not contain x, so there is not going to be any substitution. Only that we shall say, when you put a 0 here, since we don't have x here, f of x still remains as k. And also the same thing happens to 2. This also remains as k. So the coordinates become 0, k, and 2k. That will be for the first case. We move on to the next. We shall also set for 2 less or equal to x less or equal to 3. Our f of x, the function, is already given as k into brackets 2x minus 3. Then what do we do? We shall draw a simple table and summarize the coordinates. So I'll say x, f of x again. And if you look at this, we have 2 and 3 as the values of x to be considered. Then from that point, we now try to do the substitution. When I put a 2 here, I will have 4 minus 3, which is 1. And 1 times k will give us k. And when I put a 3 here, that will be 6 minus 3, which is 3, but 3 times k is 3k. So it means the coordinates are going to be 2, k, 2k, then comma, 3, 3k. Those are going to be our coordinates. Now the next thing is going to be simply taking them to the graph. And I will again label my graph as we did in the previous case. Okay, so we can now do the plotting. We can do the plotting. 0k is going to be somewhere here. Maybe I'll use a different color there. 0k. Then 2k is going to be 2 here, and k is somewhere here. I'm just trying to approximate. And if you look at the nature of this function, the function we started with, it is still going to be simply a straight line. And it will be a straight line from, I beg your pardon, this was actually for this other function, so we said that 2k. But this is, I beg your pardon about this point here. It is supposed to be 2k, so 2k will be somewhere here. It will be somewhere here, not where we had already indicated. And as you look at that being a straight line parallel to the x-axis, I will simply join. I will join it like that. And when we go to the next one, 2k again, 2k will still be there. I mean 2k will still be at this very point. Then 3k. 3 is here, then 3k is above. So 3k, if I try to locate it, it will be somewhere here. So we have that. And so it is also a straight line. We shall also join up. Now when you look at this carefully, you realize if we try to correspond these points to their values of x, we shall come up with two different shapes. For example, you can see here a rectangle and I see here a trapezium. Now later on, we shall simply get the area under that graph and we equate it to 1 to be able to get the value of k. Okay, so let us begin with the rectangle. The rectangle is here. How do we get the area of a rectangle? We get the length multiplied by the width. So I'm going to look at the length here being 2 units. So I'll say 2, I multiply by the width, but the width is this vertical distance here, which is k units. 2 times k plus, because now you have 2 figures. Now I got the trapezium. Remember the trapezium, the formula is a half h into a plus b. That will be the formula for getting the area. So I'm going to say a half h. Now I'm going to look at my trapezium in this form, so that now my h is going to be this distance from this to this, and that is going to be 1 unit. 1 unit into brackets a. Now a is going to be this distance again, which vertical distance is going to be k plus. Now it's going to be the whole of this distance, that is our b, from here to here, which corresponds to 3k units. And I equate all of this to 1. So that now I have 2k plus, this is a half into 4k is equals to 1. When you look at this, this is 2k. So it means I'll have 2k plus 2k is equals to 1. And at the end of the day, we have 4k equals to 1. And therefore, the value of k is a quarter. The value of k is a quarter. Immediately after this, we said you redefine the function. You redefine the function, so we shall say therefore our f of x is meant to be, we had k, but now our k is a quarter, for which range of values? It was 0 less or equal to x less or equal to 2. Then now we also had our function k into 2x minus 3, but we have k as a quarter, so that will be 2x minus 3 for the range of values 2 less or equal to x less or equal to 3. Then finally 0 elsewhere. 0 elsewhere. So by the time you do that, you will have successfully got the value of k using your graph by fast sketching. I am sure you have enjoyed and understood something from this video. Please make sure you subscribe, share with friends around the world, and let them enjoy the mathematics. See you in the next video.